Okay, let's open up our book to page 538, Lesson 1, Structure of Earth. Let's look at the key ideals. Earth is made up of three main layers: the crust, mantle, and core. The theory of plate tectonics explains how the seafloor spreads, how major landforms are created, and how the continents move. At the margins between plates, plates move away from or toward each other, or they slide past each other. Let's look at the top of page 538, and let's begin with the first paragraph. Please follow along in your text. Earth is almost spherical, flattened at the poles, and bulging at the equator. It is composed of three main layers: the crust, the mantle, and the core. Earth's outer layer, its solid crust, is made of granite, basalt, gabbro, and other types of rock. Under the oceans, the crust is 3 to 6.8 miles thick. Under the continents, the crust is from 12 to 40 miles thick. Below the crust is the molten mantle. It consists of silica and metal-rich minerals. The core has two layers: the outer core, which is mostly liquid iron, and the inner core, which is mostly solid iron. Extreme heat and pressure characterize the core. So let's go to the slides, and I want to share some graphics with you to help you understand the concepts in the lesson. So we're talking about Earth's core, and here you'll see the actual makeup of Earth and its crust in this particular diagram. And you can see the farmost inner core, the mantle, and other parts that makes up Earth. Now we have an additional slide, so let's pull that slide up. And here's another example that breaks down the structure of Earth. So now, in addition to the slide, we have a video as well to give you additional information. Now, as I tell the students in the class, we're going to go page by page out of the book, and we'll discuss and answer questions in class, but it's probably a good idea to go back, look at the videos, and get this additional information to help reinforce these concepts. So let's go to the next slide, and here this is a video that presents Earth layers. Let's play the video.
Hello, friends. Today, we'll learn about the layers of the Earth. The Earth is made of 4 layers: the crust, the mantle, inner core, and the outer core. Some of the layers have even more layers inside them and are always moving. Come on, let's start from the outside and move our way in. Whoa! Crust. The crust is the thin outer layer of the Earth, where we all live. The crust varies from around 3 to 5 miles thick in the ocean floor to around 25 miles thick on land. Earth's crust is found on the outer surface, and it is made of solid rock and minerals. Mantle. The next layer. The next layer of the Earth is the mantle. The mantle is thicker than the crust at almost 1,900 miles deep and makes up about 85% of the Earth's weight. It is solid rock, but not completely hard. Amazing! The mantle is made up of slightly different silicate rocks with more iron and magnesium. Tectonic plates. The tectonic plates are a combination of the outer mantle and the crust. These plates move very slowly, about a couple of inches per year. The place where the plates touch each other is known as the fault. When the plates move and the boundaries bump up against each other, it may cause an earthquake. Whoa! Outer core. The Earth's outer core is made up of hot liquid iron and nickel, and is about 1,400 miles thick. Too thick. The outer core creates something called a magnetic field, and makes a protective barrier around the Earth that shields us from the sun's destructive solar wind. That's cool. Now, the inner core. The Earth's inner core is made up of solid iron and nickel and is about 1,500 miles thick. That's too hot, and unbelievably, it's as hot as the sun's surface, around 9,000 to 13,000 degrees Fahrenheit. Now you know a lot about the layers of the Earth. Please drop a like, leave a comment, share the videos, and don't forget to subscribe.
Okay, let's turn our attention back to the text. Let's look at the next paragraph in the textbook. The theory of plate tectonics explains phenomena of Earth's crust, sea floor spreading, the formation of major landforms, and the movement of continents. According to this theory, Earth's crust is made up of tectonic plates that fit together like a crude jigsaw puzzle, like what you saw in the video. These plates move relative to one another at a rate of up to 15 centimeters, 6 inches a year. At the boundaries between plates, major landforms such as mountain ranges, volcanoes, ocean trenches, and mid-ocean ridges form, and earthquakes occur. There are 3 types of plate boundaries or margins. Now, let's look at this slide here, and it talks about these margins as well. So let's pull up the next slide. Different type of plate boundaries. You have divergent, convergent, and transform. And they use different words here in your textbook, but it referring to the same thing. So let's look back in the text. At the first one, the constructive margin, 2 plates are moving apart and new crust is forming. So that would be your divergent, the first one here that we read from the book. It will be in reference to, well, I thought we had this thing set up. Oh, here it is. So in your book, when they talk about the constructive margin, it's this one, and it shows it to you right there. So these plates are doing what? Here you can see they're moving apart. Molten material from the mantle below wells up in the space between the plates as they move apart. It hardens and forms new crust, usually at mid-ocean ridge. For example, at the mid-Atlantic ridge, new crust is forming, causing the seafloor to spread and grow by about 5 centimeters, 2 inches a year. Let's look at the next one in your textbook. At a destructive margin, 2 plates are colliding and crust is being destroyed. When a continental plate collides with an oceanic plate, the denser oceanic crust may be forced under the other plate, forming a deep trench. When 2 plates consisting of continental crust collide, the crust crumbles to form mountain ranges such as the Andes. let's look here on the slide, and you can see that this convergent destructive margin is this one. And you see what's happening here. And the trenches are forming. As well as what? As they mentioned in your book, it also causes what? Volcanoes. And then the third one, let's look back in your textbook. At a transform or conservative margin, two plates are sliding by one another, and no crust is created or destroyed. For example, the San Andreas Fault in California is the boundary between the North American plate and the Pacific plate, which is sliding northwest, causing many earthquakes. As the plates move, they carry the continents with them. Scientists believe, this is the last paragraph in your book, scientists believe that a single large continent, Pangaea, existed about 250 million years ago. And we're going to illustrate that. I'm pretty sure we have a video. I may even have a graphic where we'll show that in the slides. Let's look back at the transform plate here on the screen. So as we're reading from the text, it mentions that these are sliding. You see this plates here, and what happens? No effect. See, no crust is created, nor is any crust destroyed. That's what it mentions here. Okay, so let's close out with the last paragraph, and then we're going to show the slides and the video. So we were talking about this Pangaea existed about 250 million years ago. And what they're talking about is how Earth crust was very close together, all the continent. And you'll see that in the video. It gradually broke apart, and over millions of years, the pieces, which are now today's continents, drifted into the locations they are today. Let's pull up the slide. Let's see the next one here. So let's get rid of the marks I made. So here's a short video on plate tectonics and plate boundaries.
When plates move apart, you have a divergent boundary. Magma from the mantle wells up, creating new oceanic crust. As those plates pull apart, on the opposite sides of them, they crash into continental crust, which is less dense and thus more buoyant, causing the oceanic crust to dive under. This is known as a convergent boundary or a subduction zone. Oceanic crust dives back into the mantle where the rock eventually melts. Some of this will rise through the crust and form volcanoes. When continental crust crashes into continental crust, the similar density prevents one from diving under the other. This is called a collision boundary. The plates push up against each other, creating mountain ridges. There is one more type of boundary, where plates slide against one another. As they slide against each other, energy is stored, and when the plates ultimately slip, all that energy is released in the form of an earthquake.
Okay, so we'll stop that video. Okay, so we'll conclude with this particular slide and video where we left off talking in the book. The last paragraph in the book mentioned the Pangaea, which was a supercontinent that existed at some point many, many million of years ago. Okay, let's play the video.
Continental drift. Let's travel back in time and watch continents move. Moving back in time, the Himalayas and Mount Everest disappear as the collision between India and Asia is reversed. Climates are changing. Australia joins Antarctica as India approaches. Going back 150 million years, the continents are joined in 3 large pieces. South America and Africa are on one landmass. India, Australia, and Antarctica form a second. North America, Europe, and Asia make a third. 225 million years ago, the supercontinent Pangaea exists. Let's watch this movement as it occurred going forward in time. As Pangaea splits into 3 large pieces, the Atlantic Ocean starts to form. India starts its race to collide with Asia. As the continents take their current locations, India and Asia collide, and the Himalayas and Mount Everest appear. What is next?
Okay, so this will conclude the lesson on page 538, Structure of Earth. We will stop here.